In order to understand the proportional distribution, let's review the main components of the binomial distribution. N equals the number of trials, X equals the number of successes in N trials, and P equals the probability of success in one trial. The probability of getting exactly X successes in N trials can be found using this equation. The mean of the binomial distribution is N times P, and the standard deviation of the binomial distribution is the square root of N times P times Q. Remember that Q is the probability of failure and equals 1 minus P. For a proportional distribution, N, P, and Q all have the same meaning as they did in the binomial distribution. The difference is the x-axis is no longer the number of successes in N trials. For the proportional distribution, the x-axis is now the portion of successes in N trials. Let's illustrate this with an example. Let N equal 5, P and Q equal 0.5. The resulting binomial distribution is this, where the x values are the number of successes in 5 trials. For the proportional distribution, the x values are divided by n, which is 5 for this example. 0 divided by 5 remains 0. 1 divided by 5 becomes 0.2. 2 divided by 5 becomes 0.4. Dividing the remaining values by 5, we get 0.6, 0.8, and 1.0. The binomial distribution has become a proportional distribution. The x-axis now ranges in value from 0 to 1. The values no longer represent the number of successes in N trials. They now represent the portion of successes. For example, in the case of a proportional distribution, we no longer ask what is the probability of getting 1 success in 5 trials. We ask instead what is the probability of getting a 20% success rate. To obtain the mean and standard deviation for the proportional distribution, the equations for the mean and standard deviation of the binomial distribution need to be divided by n, as we did for the values of the x-axis. We will designate the mean of the proportional distribution with the Greek letter mu with a subscript p, and refer to it as mu sub p. It is equal to mu of the binomial distribution divided by n, the number of trials. Replacing mu with n times p, we get n times p divided by n. This equals p, which is the probability of success for one trial. The Greek letter sigma, subscripted with a p, will represent the standard deviation of the proportional distribution, and will be referred to as sigma sub p. It will be equal to sigma of the binomial distribution divided by n, the number of trials. Replacing sigma with the square root of n times p times q, we get this. A little algebra will get us to the square root of p times q divided by n. These are the equations for the mean and standard deviation of the proportional distribution. We will be using them again in later videos. Regardless of the number of trials, the minimum value is always 0, and the maximum is always 1. This is the important characteristic of the proportional distribution. It represents the portion of successes in N trials instead of the number of successes in N trials. Survey results are almost always given in terms of a percentage. This is simply the number of people responding favorably divided by the total number of respondents. Remember that a survey question is a binomial trial. Asking a yes or no question has only 2 outcomes. Will you vote for candidate X is a binomial trial. A favorable answer is a success, and an unfavorable answer is the failure. The results are almost always given as a percentage. This makes it a proportional distribution. We will be spending much more time on how to interpret a proportional distribution in later videos.